right, here we go. Today's date is 2/27/2020. All right. So our objective is graphing linear equations by intercepts. Okay? Graphing linear equations by intercepts. The word linear for us always means a straight line. Okay? The word linear for us means straight. So we're going to be graphing straight lines. So that means straight. So when we talk about graphing linear equations, we're going to draw straight lines. The equations is its name. Every line has a name, and the name is its equation. So different equations have different graphs, right? So let's take a look. So first of all, standard form. AX plus BY equals C. As an example, as an example, we did this. We just did 3x plus 4y equals 12. We just graphed that in our interactive notebook, right? We just did this one, and it's in standard form because we got sum x plus sum y equals some number. That's standard form. We got sum x plus some number equals some number, okay? Now, its x-intercept is where it crosses the x-axis. It's also when y equals 0. Okay, write that down. The x-intercept is when it crosses the x-axis. It's also when y equals 0. The y-intercept is when it crosses the y-axis, and that's the same thing as when x equals 0, okay? Now the first two graphs are actually pretty easy because we talked about these, okay? So, am I going too fast? I'll wait for you. So if I went 1, 2, 3 here, this would just be y equals 3. That's its equation. Right? It's horizontal. Has a height of 3. Always. If I went 1, 2, this is vertical, so its equation would be x equals 2. Every line has a name, and its name is its equation. Okay, again, I'll say it again. Every line has a name, and the name is its equation. Every line has a name, and its name is its equation. Okay? All right, let's keep going with this, okay? Next one. Let's go down to example 1. Y equals -3. Easy. Let's go down to -1, -2, -3 on the y-axis, right? Y equals -3 is this line. Thumbs up? It's pretty easy, isn't it?
Yes.
Okay, number 2. X equals 2. Here's my x-axis. I'm going to go 1, 2. X equals 2 is this line. That is not a function. This one is not a function. Okay, to be a function, it's got too many y values. 1x, 1y. Thumbs up? Pretty easy so far? So if it's a y equals a number. If it's y equals just a number, it's a horizontal line at that number. If it's x equals just a number, it's a vertical line at that number. Okay? All right, turn the page. All right, now, find the x and y intercepts of the graph. All right? This is not difficult. Now, first of all, I'm going to talk you through it, and then I'll show the work. For me, the easiest way is the cover-up. Let's see how easy this is. Okay, I call it the cover-up method. I call it the cover-up method. It's not very mathematical sounding, but it's so easy. Check it out. It's this easy. If I cover up the 3x, what's y equal? If I just cover that up, what's y equal?
3.
Everybody agree? Y equals 3. Perfect. So y equals 3. If I cover up the y, what's x equal?
4.
That's it. X equals 4. Or, if I let x equal 0, I get that. Or if I let y equal 0, I get that. But isn't the cover-up method easier, right?
Yeah,
Right? You just cover up and solve, right? Okay, 4. Okay, if I cover up the x, what does y equal? If I cover up the x, what's y equal? Negative 4. Yeah, y equals negative 4. Perfect. If I cover up, hold on, let me cover it up with a small piece. Okay. If I cover up my negative 4, what do I got?
16.
Negative 16, but you got the right idea. You guys okay with the negative 16? Cover that up. X equals negative 16. So, or if I let x equal 0, I get that answer. And if I let y equal 0, I get that answer. But it's so easy just to cover it up and do it in your head, right? You guys agree? Okay. Okay, number 5. Right? Let's do number 5 real quick. If I cover up the x, what's y equal? 15. Right? Y equals 15. Okay, if I cover up the x, what's the y equal? Can you see it?
You can cover the y.
Yeah, cover up the y, that's what I meant to say. Yeah, thank you. I get a negative 6. You can see negative 6? So I get x equals negative 6. Okay, let me do it this way. Watch. It's kind of fun to do it this. We were talking about this. At lunch, weren't we? I can cover things up. Okay, check it out. I'll do it another way, okay? Here. Okay, watch. If I cover up the 5, that's cool. What's y equal?
16.
Negative, positive 15. See it? Divide by negative 2, divide by negative 2, right? You guys see it? That's what I'm doing. Yeah. And then, hold on. Erase. And then, watch this. If I cover up the y, right? Cover up the y, divide by 5, you get negative 6. Okay? So now, we can put these numbers on a graph. And all you need is 2 points for a line, right? So let's do that. So let me go ahead and erase what I got up there. Come on now. Erase it. Okay, so now, if I have, let's go back to the first one, number 3. I have a y at 3, 1, 2, 3. I have an x of 4. See it? I have a y at 3, 1, 2, 3, and I have an x at 4. Connect the dots. You have a line. Every line has a name.
Linear.
And it is linear. Yes. Okay. Okay, graph number 4. Y at negative 4, that's going to be down at 1, 2, 3, 4. And x is at 16, which is probably going to be off my paper, right? Negative 16. All right. We can change our scales. Let's change our scales. Guys, let's change our scales. Let's go 4, 8, 12, 16. Let's go negative 4, negative 8, negative 12, negative 16. Yeah, let's just change our scale so it fits, right? So I'm going to have a dot here at negative 16. Connect the dots.
Wait, that would. The bottom was
4, 8, 12, 16, huh?
No,
Tim?
the bottom negative 4, don't you have to change the y scale just to match the x?
No, great question. You don't. You don't. No, in fact, a great example of that is a real life example, okay? How much a car is worth over years, right? So cars are going to last 1, 2, 3, 4. The longest car might last 30 years, right? But your car starts at maybe $40,000. So the scales, oh, well, some people buy $40,000 trucks. So There are $60,000 trucks out
Come
there. They're
in.
pretty sweet,
That's
but
cheap.
I don't got one, huh?
That's cheap. 60,000 for a truck is cheap.
Isn't that crazy?
They're more like 70, 75.
There you go, 75,000 for a truck?
Not the Tesla.
So your scales are definitely different, aren't they?
Tesla
Yeah.
truck?
Tesla truck's 40.
Okay,
The base model.
so probably on 5, let's change our scales on 5. Let's go and change this to maybe, let's go 3, 6, 9, 12, 15. Okay, I'm changing my scales there. And I'll go 15 and -6 is 2, 3, 4, 5, 6, maybe there, okay? All right, how am I doing? Okay, last two, let's do it again. Last two. So, same thing. So if I cover up and solve for y, what's y equal? If I cover up, what's y equal? What's y equal? Okay, 24 divided by 12 is 2. So y equals 2. If I cover up, let me cover up this way. Okay. If I cover up the 8, I get a 2. Positive 2, good. If I cover up the 12, or excuse me, if I cover up the y, what do I get for the x?
3.
Negative 3, agreed? Negative 3? Okay, good. Okay, -3. Okay. So then I get a x equals -3 because I let x equal 0 and I let y equals 0. So all I have to do is graph these. Okay, so I've got a -3 on the x. That's there. And I've got a 2 on the y. That's there. Connect the dots. We got a line. Last problem and I'll be done. Okay? Almost there. Okay? So, cover up the 2x. What's y equal? 4. It's just already solved. Agree? Y equals 4. Cover up the y. What's x equal? 2. Isn't this easy?
Yeah, it's big easy.
So we're going to go to 4 on the y, 2 on the x. Now that's a lot easier than plug. Remember how we did it before? We had to plug in numbers. We plugged in 1. We plugged in 2. Isn't this easier?
Yes.